All right, let me give a little walkthrough here. So of some of the new features. So first of all, there's like a new add command. So like here's kind of like a fresh repo. So if I do like elm-pages add index, so that's like a module name, and then we can start up the server. This is like a totally fresh project. So so let's pull up that index file that we just generated here. I'll bump up my font size. It's always hard to find the right font size. There are like 3 different places for it. I think this is it. There we go. Not an IntelliJ. It's very advanced technology, you know, so. Yep. Hey, Sev. Good to see you. It's going well. I was just starting the sneak peek, which I think will not be anything new for you, but should be fun. Okay, so we just did elm-pages add for this index page, which is nice. And this is what it looks like. So this is sort of like using this like template modules approach. It's evolved since then, but that was like sort of the prototype for these file-based templates. Except now it's file-based routing. So there's no concept of metadata or rendered body. So like this page, so like often in elm-pages 1.0, you would have like an empty markdown file that just had like some metadata, and you would use that metadata to say this is just a regular page and use that for the routing. You don't have to do that now. You can just create page.index, and then you've got an index page. And if I wanted to have an about page, then I could do elm-pages add about, and then go to the about page, and the dev server picks it up. It's ready to go. So that's really handy for that specific use case, but it doesn't just support one-off pages. So notice this is like a single route, but we can also handle parameterized routes. So this is what that looks like. We would do elm-pages add. So this is very much like elm-spa, which is inspired by Nuxt heavily for the routing convention. So if we wanted to create a repo.name, the name has an underscore after, which means it's going to be a parameterized route. So that's a dynamic segment. So that means if we go to repo/elm-pages, it's giving us this error. So let's look at the generated file. So here is page.repo.name underscore. And so notice this is the scaffolded page. It's got these route params, which is name string. So that's straight from that dynamic segment. If I tried to make it, route int, it's a compiler error because the generated code expects it to be matching this specific convention. But so the way it works is sort of the generated scaffolded file. Usually you're just not going to touch that, or if you need to, the compiler will tell you what you need to do. So So I ran into a call to datasource.fail and noticed that we're getting these like Datasource error messages live in the dev server. So let's try to make that go away. Okay, so routes, let's just make it empty. Now it's page not found. So these are like, right now it says pre-rendered routes. I might change it to like build time routes. I'm still sort of iterating on the name. But so we say name equals, so let's do elm-pages. Now we've got that route. So if I go to repo/elm GraphQL, that page is not found. If I run a build, npx elm-pages build, then it's running Cursor and all that. It pre-renders repo/elm-pages about and slash. So that's pretty neat. But now notice this is a data source. So if we wanted to, we could use a different data source to get that. Like if let's see, what would that even be? Users. Oh, yeah. Looks like that is it. Okay, so so I could create a route for each of my repos. So let's say like all like my repos. Let's just make a data source. So data source. So it's called data source now. This used to be static HTTP. Data source get secrets.succeed, because we can pull in secrets, which will be excluded from the production bundle if we want to, but we don't need any secrets because we're doing an unauthenticated request here. And then I need a decoder. Well, it's a list. This is an optimized decoder, which means it's just as with elm-pages 1.0, it's going to strip out any unused JSON data. So a list of field name, the repo name, string. Oh, I did decoder. I usually like doing decode. Okay. So, is it happy? Yeah? Okay. So now, let's replace this placeholder with a proper view. So okay. So let's just say static dot I haven't wired in the data. So let's see. But what I really want to do is I want to create routes based on that. So, well, actually, first, why don't we try creating a listing page for repos, and then we'll create a route for each of those repos. So, so let's see. So like if I go to just /repo, let's show a list of repositories. So, so how do we do that? Well, it's going to give us not found right now. But if we do this as an optional dynamic route segment with 2 underscores instead of 1, then that's going to allow us to handle both repo/repo name or just repo, which means this is going to be a maybe string. If I save, it's going to give me an error. And well, it's going to give me multiple errors. Let me rename this the proper way with the IDE. There we go. Wait, why won't you rename? Name underscore underscore. Okay, so now I'm renaming the file and the module name. Now it's going to give me this error that says it expects it to be a maybe. Okay, so let's make it a maybe. And this is not a maybe. List. Oh, yeah. Whoops. Put the just in the wrong place. There we go. It's a good thing there are good error messages, because otherwise that would have taken me a long time. So, all right. So page not found repo is still not found because, well, we're not including that route. So let's add name equals nothing. And now that route is found. So now we can handle that route, which in some cases is handy. Actually, I've just illustrated that feature, but now that I think about it, that's actually not what we want conceptually for this case. So like, what this would work well for is like typically, if you want to have like a default, so like if you go to /repo, it gives you the default repo. That would be when that would usually come in handy. So let me back that out. And let's go back to what we had. Okay, so it's not finding that. That's good. So really what we want is we just want to add like a new route for repo. Okay, so here's our repo route. And let's take this data source we were working on. And get our imports. And give this a type annotation. Okay, so let's wire this up. So this is what it looks like in elm-pages 2.0 to wire in a data source. So instead of having to map it and have this wrapper around your view and head types, it looks a lot more like you know, a browser.application sort of thing. It is actually using the builder pattern too, so you can like include local state or shared state to send messages, sort of like out messages to update the shared state, or you can just do a stateless page, in which case you just need to define what your like SEO tags are going to be and what data you want. We're not pulling in any data right now, so let's just go ahead and pull in my repos as our data, and our data type then should be list of string. So let's see. So repo, there's our repo page. Now, let's see if we've got our data. our static.data, and for now, let's just do string.join and have that as text. Yep, it works. Cool. It's a whole bunch of random repos. If we wanted to get fancy, I mean, these are just decoders. We could, add API parameters. We could get the Stargazer count, which looks like what? Stargazers count? Why not? Let's grab the Stargazers count. List of repo, can't string.join, list.map name. Okay. Let's just do list.map to a list item. Oh yeah, I'm not doing list.map. List.map. Okay, that's better. So, and let's just grab the name like that. Okay, so, so anyway, this is pretty nifty because we can wire in this data source just kind of by declaring it. So I really like that. So you say data source. We declare this data source, which is wired in here. It's similar to like how you wire things in browser.application. You wire in your subscriptions, and then you just have it. You just have it where you need it. You have it in head if you wanted to pull that in to head. If you wanted to pull that in to your view, it's just there. And then now, well, let's make these links. So. We'll link to /repo/name. Oh yeah, make some local files. That's a good idea. Yes. So let's see, CSS, let's just underline those. Oops, not CSS, but Tailwind. Okay, so we've got links. Let's Let's give this a little bit of padding. Okay. So let's click to one of these guys. And let's just, while we're at it, let's get the stargazers. Did I get that correctly? Map 2 stars. Yeah, I did, because I would get an error, which is, I think this is an amazing workflow to just like have a decoder against an API request, and you do this. So like the amount of setup that you would need to do if you like just create a new Elm application, set up a dev server, get it doing hot module reloading, wire in you know, the loading state, the error state, all these things, get nice error messages. And in fact, even if you did all that, like, it's not even gonna, if you do hot module reloading, it's not gonna rerun your requests. And anyway, I think it's quite a nice workflow, and like really nice to iterate on apps like this. So okay, so we've got our stargazers count, and let's just like filter stars greater than 10. Oh, and I need to get multiple pages of data probably. Well, stars greater than 2. Okay. Well, there we go. There's some repos. So I guess alphabetically, my early alphabetical repos don't have a lot of stars. So if we click on this link, it takes us to that URL, but our dev server is saying it's not found. And that's because we've got these, this is the only route it knows about. If I had this here, then that would work. Then it's found. Now, and let's just, we should at least, so we've got the static route params name. So we can just show the name there. So I've got to add some padding. Sorry. I'm not a designer, but I'm also not a barbarian. Okay, so we want to pull in our routes to sync these up. So let's do that. So first of all, I should I think this is like a common thing with the 2.0 I'm finding, is that, you know, I mean, this is like a similar sort of approach that Next.js has, compared to something like Gatsby, where everything is this centralized mesh that you kind of put together up front. It's more of a pull model than a push. Gatsby is like a push model. You push in all your data to this data mesh, and then you get it when you need it in GraphQL, but you've kind of had to load everything up all at, you know, all into one central place. Whereas Next.js, you just pull in data if you need it for a particular route. And it's the same sort of architecture with elm-pages 2.0, which I'm really enjoying a lot. George is saying, since the in-page route data config is so simple, I wonder how things look like in the top levels. Shared, yeah, I will definitely show you that. Things like shared data source, yep, that does exist. You can have shared data between pages, and I will show you that totally. So let's see. So because we're pulling in data as needed rather than pushing everything to a central place, that means that we're going to want to share some of that data, not by putting everything into a single mesh like this sort of push model of Gatsby. We're still pulling the data, but we can share it by abstracting helper functions, just like we share things in Elm otherwise. So, so let's take our my repos here, and let's just what do we want to call this? Repo? Let's just make a repo module. And so we'll say data is repo.myrepos. And then list of repo, well, I don't want to say repo.repo, so I'm going to import it. Okay, so now we're sharing, well, now we've extracted that out. Let's use it to create our routes. So repo name, and our routes is going to be routes. We're not using this. Repo.myrepos. But the type isn't exactly the same. This is, so we'll say list.map a repo to name equals repo.name. Aha. Datasource.map list.map. There we go. So if we were to, and you know what? Let's, so in our, I need to close these pages because I keep wanting to go to them. Okay, in page.repo, we're filtering out repos that, unless they have at least 2 stars. But let's pull that into our data source here. So let's just do datasource.map, list.map, repo, list.repo. What am I doing wrong here? Argument is data source list repo, piping it to something that expects stars. What am I? Oh, I don't want to do list.map. Aha. Okay. Okay, there we go. So now we can get rid of this filter here because we're filtering it down. And we can the nice thing is the nice thing is that now when we do a build, elm-pages build, be a little bit faster if I did it with debug because it wouldn't have to run Cursor and Elm Optimize level 2. We are we're only pre-rendering exactly those routes because that data is in sync. So that's really nice. So sure enough, if we go back to repo, click here, click here, click here, it's finding routes for all of these. And of course, now, okay, we've successfully, rendered a, the name of a repo that we just clicked to. That's nothing interesting, of course, but we have the full power of data sources here. So we can say, let's see. So if you look at our data for this repo page, so page.repo.name, which means we have a route param called name, which is a string. So notice that data is given the route params, what data do you want to pull in? So, well, let's pull in, let's go back to our repo here and let's just like share this decoder. So repo decoder. So we've got this repo decoder, and now we can use that to make our data source request. But we're going to have to make a different HTTP request. So let's do that. So for given these route params, let's make an HTTP request to api.github. Something like this. And then let's do that, and the data is going to be our repo type. Okay, so static.data.stars. Now I've hard-coded the URL. But let's go ahead and there's the URL. Let's use our route params. So route params dot name. There we go. All right, there are the stars. Oh, 42, that's a lucky number. So now we can go to a repo. Notice it's waiting for a moment. Let me just show the dev server fetching this URL. So it took 461 milliseconds. If I hit refresh, then it took 87 milliseconds. Because it's using the cached response. So it's only fetching it on demand as needed. So if I click on this, I'm gonna oh, that was already cached. If I click on Automated Testing Wiki, 500 milliseconds because it was actually performing that HTTP request. Refresh, and 93 milliseconds because it's cached. If we look at the static HTTP cache keys, which I'm just printing for, verbose logging here, it's got this cached static HTTP request. So that's kind of that's something I'm very happy about with the elm-pages 2.0 architecture. It's pulling data in as needed rather than this push model of build the whole world. In order to get any data, I need all the data. Let's get all the data first, and then let's go and build a particular page. With elm-pages 2.0, the architecture is such that you only need to pull in the data you need for a given page. And it's split out that way. And the dev server only handles it that way. And that does mean that if there's a data source error in a page you're not looking at, you're not going to see that error. If you do a build, you'll see that error. I think that's a fair trade-off because the performance is a lot better there. So okay, we had a few questions. So let's let me show a couple of the things that George and others brought up. We've got so shared. We do have shared. Let's go to our shared module, and so if we want to get a data source here, well, let's just say. I don't know. Is there like a dad jokes API or something? What do we use for the shared thing? Users, Dylan, current. Yeah, I don't know. Well, let's just say succeed. Hello from shared. So. Our shared data is going now, and I've gone with I'm really liking these sort of like simple one-word names. So shared.data, it fits right in with shared.model, shared.message. Shared messages like these out messages. So hello from shared, and now we've got access to that data. So if we want to pull that in our page here, it's just static dot shared data. There it is. Hello from shared, and we can whoops. Change that, and it changes. Same thing if it was an actual data source, or if it's data source.fail, we get this failure message. So that's pretty nifty. Let's see, other things. So site.elm looks like this. So I've also given like a definition of data. So you can define a data source for site.elm. That's better. So that's cool. So you've got this data. If you want that data for defining your, if you've got a CMS that you want to use to define your canonical site URL, or if you depend on your CMS for your manifest, then you can do that. Also, I've got like this, the manifest API is like this builder style API. I've also even included like, you can say with lang, and you can use my BCP47 API to give a language tag. So I've made some refinements to those APIs. Let's see, what else? API routes are really exciting. So if we go to repos, in our repos project, if we go to api.elm, we can define these API routes. So I don't have any API routes right now. So let's say, like, like, let's make some like information about repos. So where do I want this to live? In repos. I'm going to do this in VS Code because I prefer VS Code for Markdown. So, oh boy. Okay, so let's make like a, oh boy. Okay, maybe not VS Code. I'll make a folder called like repo info. And then let's make a file called automated testing wiki.md. And I'll just say maintenance status, not actively maintained. Background, I made this to jot down some notes a while ago. Guess it's got some stars. Okay, so there's our document. If we wanted to create an API, an API route can be a lot of things. Like so if we go to API, we could say API route. Let's see, how do I do this again? API route. Can't find Datasource. Let me go to another API example just to refresh my memory here. Well, here's some real stuff. I'm just going to, let's see, api.succeed, datasource.succeed, body. Oh, yeah. And then build time routes. This is just a single route. Okay. So let's see. So if I go to, this is example.json. It's not really JSON, but that's okay. So that's how you define like a file generator. So like if I run the build, let's do it with debug, so it's a little bit faster. Invalid or unexpected token. What's that? Okay, I guess the debug thing is unhappy. Generating file example.json. So it writes this file to disk. So it's called API routes because you can sort of, you can build APIs where you have full access to data sources, which is really exciting. So if we wanted to, if we wanted to say like, let's see. If we wanted to say repo slash let's do like API slash repo slash and then capture name .json. Now it's unhappy because I'm capturing an argument. So let's say given name, and I can't say single route because it's a parameterized API. So let's do build time routes. Build time routes. So, oh yeah. This is really exciting. We can use data sources to build these routes. So if I want to say automated testing or testing wiki, can create a route for that. So API repo automated testing wiki.json. Let's just give the name back there. There's the name. So we can make arbitrary HTTP requests for data sources here, and it's going to do that when we request that resource. And these are build time API routes, so it's going to generate those in our build, and then they're just static assets on the CDN. But we could do on server request too. I'm still sort of iterating on that, but you can sort of imagine you get access to the incoming request payload, and you can use that information, including headers, query parameters, dynamic information, to then perform an on-demand request and return an API response just using data sources with pure Elm, which is kind of nuts. So let's see, what else? Yeah. So oh yeah. So getting files. So let's say routes. What do we want our routes to be? Well, let's take our repo info. Let's do a glob for that. So like glob dot capture. Okay, so datasource.glob, glob dot literal repo info. We don't want to capture that. We want to ignore that. So this is similar to like the Elm parser API where you sort of capture and ignore, except instead of the operator, pipe equals pipe dot for ignore and capture, that we're using the English words because we can't do operators. And also this is pretty readable. So let's see. What do we want to capture? We want to capture repo info oh yeah, well, we capture wildcard. Let me define this over here for a second. Okay, so we want repo info wildcard. So repo info / automated testing wiki .md. So we can capture this name and, well, just pass it through, and it's going to be a glob of string. So it's just grabbing the name. So we could just take this glob. We can say glob to data source, and then data source.map each of those into routes. Repo info. Let's log this. glob is empty because I'm probably messing something up with the slash. Let me find a good example. Well, here's an example of some globs. Oh, I need the slash. Okay, so it's repo info slash wildcard. There we go. Okay, so now it's finding this file. If I put another file in here, elm-pages.md. Why is it not finding elm-pages.md? Repo info. I'm not sure why it's not. Let me restart the dev server and see if that... Okay. I think I need to clear that cache. But maybe I'm not doing that for API routes. So anyway, this is pretty nifty because you can do these glob, like, so let me show an example of like the globbing API. So globbing. So this is super cool for these blog posts. So we're capturing the full file path, similar to Elm parser, how you can get the sort of I don't remember what the term is used in the Elm parser APIs, but you can get the captured thing, the full thing. So this is going to be a file path that you can read because it actually matched this file path. So let's capture that file path. In fact, that's all we want, but we want to match content/blog/star.md. We're ignoring everything. All we want is the file path that it matches. If we wanted to, we could capture bits of it and turn that into an Elm data type. And then let's take that as a data source. And for each of those file paths, if it's not index, then let's get that file. Let's parse the front matter for that file with our front matter decoder, which is just an optimized JSON decoder, just a drop-in replacement for Elm JSON. And then let's, this is just, combine is just taking a list of data source and turning into data source list. So that's really cool. Oh, I guess I have this is the actual request it's using. That's unused code. Interesting, but that will still work. But so I guess what we're actually doing is we're getting the body, we're rendering it as markdown, and if there's an error, we fail the decoder. And we're parsing the markdown. You can do a lot of cool stuff with that. Like for I've got this slides example repo. Where I am pulling in this data. So for each of these level 2 headings, I'm splitting it into a different route, which is really fun. So like here, I can show the repo. Slides, npm start. Do I need to install npm I and npm start? Oh, I probably changed something. Okay, I'm not going to show that right now then. But you can check it out on GitHub. I'll have to update something. But yeah, so that's, let's see. So I think that gives the gist of a lot of the things I wanted to show off. The really cool thing about data sources is elm-pages doesn't care if a data source came from HTTP, succeeding a data source, pulling it in from the file system, doing a glob match, it doesn't care. As far as it's concerned, it's just a data source. You could map all those together. You could take some data from a CMS, some data from your local file system, some data could be hard-coded, and you could combine all those together and concatenate them in a list of blog posts or whatever. Elm-Pages doesn't care. As far as it's concerned, it's just a data source of a particular Elm type. And all it cares about is that Elm type. So let's see. So let me, okay, so let me kind of go through a few of these points and then we can sort of open up the discussion. So, so we did our sneak peek. Let me talk about some things that I want to declare success on, which is sort of like a year or so ago when I did a community call, I used that format. So I want to look back now and say what can we declare success on, and what might we want to rethink, and what has been rethought for 2.0, and then what are some things that I'm thinking about on the horizon. So, okay, so is this declaring success? Is that what I'm? This should probably be declaring success, but. So I mentioned the dev server that we're doing just in time now, which is really cool for performance. We can see errors as we saw as you're changing things, whether it's an error in a data source or an error in the Elm compiler. That's super cool. It also refreshes, like, you know, if you've got a blog post, like, for example, let's go to the docs site for 2.0. So I'm working on these new docs. And so if I go to, like, what is elm-pages? If I go to this and say question mark, and save, it live reloads. So live reloading works even though you can pull in any data source. It sort of knows, okay, well, this page depended on this glob and this file data source, so we need to watch for changes there, and if they change, we need to pull in that fresh data. So that's super exciting. Architecturally, the things that sort of just-in-time approach has opened up are really cool. We can give even 404 errors without building the whole world. So, like, basically the new architecture is, if you give me a URL, then I can tell you how to map that into a page or an API route, which opens up a lot of cool things architecturally. And also, I think it's a really nice way to think about things as a user. So that's like a huge win. So other things to declare success on, static HTTP, I think is the core of elm-pages. You know, like, there are certain things that I've been rethinking and saying, like, can we just get rid of this concept entirely in elm-pages from the 1.0 to the 2.0? For example, the concept of metadata, it's in the trash can. Good riddance. Now, it was really difficult to figure out how to enable those features in a different way with a new architecture. But once that clicked into place, it's so much better off without that. But some things that have stood the test of time, I think the static HTTP concept, that is, like, so much at the core of what I see as elm-pages providing as its value proposition. So let's double down on static HTTP and let's do more with it. And in fact, to reflect the fact that we're doing more with it, let's call it a data source, because it's not just HTTP. We've got file data sources. We can glob as a data source, maybe even JavaScript. So that's something I'm exploring right now, is possibly having something that would be similar to, like, how you wire in a JavaScript port. So you'd have, like, a data source where you say, you know, give me, I mean, you could even like make a request to a database or call out to an NPM package, and you just get JSON data back, just like you do with any data source. A data source is fundamentally just getting you JSON data for the pages as you need it, and then making sure to include it in the page so it's loaded by the time your page is rendered. Optimized decoder, I again think that's a concept to double down on, and all the more so let's do more with it. So like one of the themes of elm-pages 2.0 for me is like removing some features and in place doubling down on building blocks and letting you do more with them. That's something that I think like feels really good about Elm in general, is like Elm has these great building blocks and you don't need a bunch of fancy things. You could just sort of like do so much with those building blocks. And I feel like elm-pages 2.0 has gone in that direction too, of let's make great building blocks that are solid at the core. And I think the concept of optimized decoders has been working well. Even more so if we can use them with distilling data sources, where you can say, hey, the result of all of these fancy computations, I'm pulling in all this markdown, I'm pulling in all this data, but at the end of the day, I'm trying to get a table of contents of all of the headings. So let's just distill it down to that data and forget you even got data from those sources. The template modules beta, I think, was a success, but one thing I learned from that is so like the concept of having, instead of having like static HTTP wrapping your view and head in the sort of original Elm pages, it's so much nicer to just have data that's sort of this declarative thing. Here's the data for this page, for this type of page. But some things to change that I've learned for 2.0 that have evolved from the original template modules beta are, instead of saying a particular template module maps to a type of metadata, like a blog metadata or a page metadata, instead it is a one-to-one mapping of this route, page.index, page.blog.slug _ page.repo.name _ that route maps one-to-one to a given module. So if you know the route, you know the module. If you know the module, you know what routes to expect. So that's working a lot better. So let's double down on that idea with this sort of new mental model. And so from the sort of 1.0 template modules beta, the name has gone from template modules to page modules. We've got file-based routing, and from using it in the alpha period myself, I love it. It's feeling really good. It feels really nice, just like pulling in data sources based on the route params, for example. Some refinements. For the 2.0 release, I'm trying to use more builder pattern to reduce noise and be more resilient against breaking changes. For example, in the manifest API. Okay, so some things to rethink. I want to rethink some things from the ground up. So the architecture I talked about, instead of big batch, build the whole world, let's do one piece at a time. So if you give me a URL, I can render that page. That actually opens up some really interesting things, because that means now we can do serverless responses. So now we can say, hey, somebody just hit this URL, but there's no pre-rendered page for this. Can you handle it? And then in a serverless function, we can run the elm-pages engine for serverless requests that you've defined and say, oh, let me check if I want to handle that. And then you run your Elm code and you say, oh yeah, I do want to handle it. Here are the HTTP response headers, status code, and body. So that opens up some really cool things architecturally like that. Changing direction, again, removing some cruft of some features and instead having really powerful building blocks that enable you to derive those features very easily and simply. For example, the generate files API is now API routes. So that is a much more powerful building block. And in fact, it's emblematic of this big batch to one piece flow direction as well. Instead of saying, okay, here are a bunch of files to generate, it's actually now, here's a route, here's an API route. And when you hit that API route, here's how you render it. And you can either say, okay, here are the routes that I want at build time. These are the known list of routes, just generate these files, or it could be a single file, or it could even be serverless. So it opens up that direction too, which is really cool. Metadata and rendered body is gone. Instead, we've got page modules, and you can pull that in as needed. If you don't need metadata for your index page or for your blog listing page, if you don't need metadata, you don't need to force it. You just pull in what you need. And if you don't need metadata, you don't pull it in. If you don't need to render markdown for a particular page, you don't pull it in. If you do, you pull it in. If you need to render 10 different markdown documents from different data sources, from HTTP, from a file, you pull those in. So you're not limited. That's sort of breaking out of the mold of being locked into specific features, and instead of having really powerful, simple, elegant building blocks. That's the goal of elm-pages 2.0. So you pull it in as needed. Doubling down on the architecture, what could we do down the line? Incremental builds, faster dev server. We could even check if the AST has not changed around Datasource or any of the dependencies for your data source for that page. We could do some interesting things on the dev server or in incremental builds around that. Having these different files like the site.elm, api.elm, and then the page modules in page/blog/slug_.elm, index.elm, page/index.elm. That opens up some cool things where we can say, well, in the production build, we don't need to include the API routes for the front end build, because that's only run on the build process. So, this philosophy is moving away from this sort of Gatsby push model of data and moving more towards this Next.js model, and also embracing this sort of Next.js concept of the hybrid routes. So pull in data as needed instead of having to get it all up front. More flexible, less dependent on an opaque plugin API. It's just functions and data. Pull in data as you need, abstract things out to functions. That feels very Elmy, which is awesome. No more metadata, and you can pull that in as needed. And the dev server can be much more performant as a result as well. Okay, and then more lightweight types. So elm-pages 2.0 doesn't have pages.pathkey anymore. There's no more pages.pages, there's no more pages.images. Instead, we've got a route type, and you can refer to that route type. So like in our example of our repos, here's the generated route module. We can use these. We can refer to routes. We can say route to path if we want to link to it in a type safe way. So if we link to about index repo, we're going to get a known static route. If we link to repo name, we're going to need to provide the dynamic portions of the URL. And I'm considering some ideas for possibly providing a way to hook in so you can use elm-pages, so you can use Elm Review with some generated code that elm-pages can give you to say, okay, well, these are the statically known repos, or this particular route is a serverless on-demand route, so it could potentially be any route, for example. And that means you don't have to incur the cost at build time or in your bundle. Instead, you incur the cost at dev time. If you want to run the Elm Review rule, and it's a minimal cost, but at least you can strip that out of your bundle and simplify there. one of the things that I've done with the 2.0 that I'm very curious to hear feedback on is I've gone with this approach of BYOB, which if you're not familiar with the term, it means bring your own bundler. So no more. So elm-pages 2.0 currently doesn't do any JavaScript processing whatsoever. And now if you don't have any NPM packages or anything like that, well, that's great because you don't have to incur the cost of doing JavaScript bundling and pre-processing. If you pull in a couple of native ES module imports using modern browser import syntax, then that works really well. If you just have a few dependencies and you can pull it in like that, then you don't need a bundler and you don't have that much JavaScript, so it works out fine. If you really have a heavyweight JavaScript in your elm-pages front end, then you can always pull in Webpack or Rollup or whatever you want as needed. But the way it works is elm-pages just gives you a single JavaScript entry point file, and it doesn't do anything with that except copy it over and include a script include tag of that. So that lets us have a leaner build process. We've also, elm-pages 2.0 doesn't do any image processing. The image processing in elm-pages 1.0 was like a hard-coded, transform these specific file types to this specific quality, 80% quality with these settings. That was never a permanent solution. That was an experiment. And I'm going to, cut ties with that experiment. And going forward, I've kind of come to the conclusion that image processing is best done outside of the elm-pages build. A lot of frameworks are moving in this direction. Next.js released their image processing API, which does it on demand in these serverless functions, which is really cool. You're seeing some services that like go into a GitHub repository and produce optimized assets, so you don't have to do it on every single build because it becomes the bottleneck very quickly. And that's something that I think we're seeing a lesson learned from Gatsby, that people are starting to say, this image optimization API that Gatsby had seemed really cool. And then as your site grows, it actually becomes the bottleneck and makes working with Gatsby really painful. So let's learn from that lesson and leave image optimization to these other approaches. I'm a fan of Cloudinary. I think maybe the pricing can be a bit steep if you have like a lot of images. For me, I've been able to use the free tier. It's worked well for just saying, okay, here are my images. Figure out how to optimize them on your server. And it takes care of caching it and optimizing it and giving you really nice images. Some things on the horizon. So serverless. Serverless is in the alpha right now. Serverless rendering of API routes and pages, which is exciting. I'm still sort of refining the API around that, but the prototype works and it's awesome. It's exciting. Full stack JS ports could enable things like calling Prisma to hit a database and grab data and even insert data. Using things like Netlify's new distributed persistent rendering, they also call them on-demand builders. That's a really exciting area where you could say, hey, these pages of, these are from the blog archive. So I've got 1,000 blog posts, but let's pre-render the 50 most recent or popular, and for all the 950 others, let's not pre-render them, but let's pre-render them on demand in a serverless function, and Netlify will cache the results of those. So we're building them on demand when somebody requests them, and everybody else who requests it gets the fast cached response rather than the serverless response. Another thing on the horizon, so with serverless rendering, so this I think of it as, this is like the elm-pages engine, this thing that says, okay, here's a route. What's your response to that route? Which can either be, in the dev server, it will respond with like these pre-rendered things. when you ship it to production, it's already built those assets, so it's not going to hit it for those pre-rendered things. But for these serverless things, it can respond on demand. Well, that means you may have a failure that you don't know how to handle. So now, how do you want to handle that failure? So I think having like a failable static HTTP request or datasource.http is something I'm planning to explore. Just in general too, like, if you want to authenticate a user, you want to call to the auth0 API and try authenticating this user with the header that came in from a serverless request. And then, well, what if you get a, 401? Well, right now you just get a 500 on the entire render of that page, but you might actually want to say, hey, if I get a 401 unauthorized, then let me render a page that says, looks like I couldn't log you in, and gives like a nice page for the user. So, and now this serverless stuff is really cool too, because you can use elm-pages to do sort of paywalled content, or if you have like a paid course and only logged in members can view that, it opens up use cases like that, which I think is really exciting. Plugin API, this is still something on my mind for definitely not 2.0, but I'm still thinking about Dino style access control for plugins. What could that look like? Right now, I've sort of split off these API routes into an api.elm file, which architecturally is nice because I can watch for changes to that file and figure out how to do the minimum amount of work in the dev server to get really snappy reloads. But then there are these global head tags defined in your site.elm, and they're in two different places. But what if you want a plugin that says, well, here's an RSS plugin, and it needs to add a global head tag and an API route for RSS.xml. What's the best way to do that? Is it okay to call this, little RSS plugin and add things to two places? Is that fine, or should there be some sort of API design to help with that for plugins? And what are the performance implications to that for the dev server experience? And then a big one I'm thinking about too is like for CSS and JS, should there be a way to add script and link tags? So right now there's an index.js and a style.css, and elm-pages imports those, and that's it. That's like a hard-coded thing, and you can use you can do any pre-processing you want. You can run Webpack to build that index.js. You can run Webpack to, or is that a thing, to pre-process that CSS file? Or you can, whatever you, however you want to pre-process that CSS file, or you can use ESM imports in your index.js. You can use, style sheet imports in your CSS file. But should there be some API where elm-pages allows you to define some assets to load? Sometimes people will include Google Analytics or Intercom or these different, script tags that they need to include. Should there be some path for that? That's something I'm curious for feedback on. And what would the API look like? Where would it live in site.elm? All right.